In the previous video, we created a simple Python server, but there's a few things that this server cannot do, and one of those things is multi-threading. So it can the what you have right now cannot handle multiple clients at the same time, or it cannot handle multiple requests at the same time. To help us to rather to test this out and see how it happens. As you can see here, we have our browser. We have only one tab open. I'm going to open a new terminal here, and we can just use simple curl to try and send multiple requests and see the kind of responses that we get from the kind of response that we get from our server. So I'll just say http should be http, then we'll say localhost port 8080. That should be it. Then we run that. You can see we get hello world. You can send multiple of these requests. And if we come back here, okay, this is what we have. I'm going to get rid of one of them. So if you come back here, as you can see, we're sending multiple requests. The requests are being received on this other end. But if we open multiple tabs, for example, on our browser, if you open multiple tabs and try to send multiple requests to the server, then the server doesn't handle them well, or it doesn't handle those multiple requests as we would like it to handle. So to help us do this, we'll start using threads. And to use threads, there are a few things that we can do with threading. The first thing we need to do is we need to import threading. So we'll just import threading. And after importing threading, we am going to create a simple function here, and we call this function handle client underscore client. What this function is going to take in is the client underscore socket, and I'll actually just create it right here. So I'll create the function there. So we'll take it's going to take in client socket as a parameter. And there are a few things that we did here that are going to just change up a bit. So in this case, we're going to maintain this. So we're going to still maintain, so we can, where the connection is coming from, we can maintain that, or just get rid of it entirely as well. Then we're receiving the requests here with 1024. And then the other thing that we need to do here actually is we need to extract the request path. So to extract the request path, we just need to modify our server so that it can be able to pass the request. And how it does that is quite simple. Quite simple in terms of how it does that. And what I'm going to do is right after this, we can create a variable here, and we'll call it request underscore lines. And what this is going to do, it's going to take in the request, then it's going to split that request, and it will split it here. So \n. And then we'll now take a single request line. So we'll just say request underscore line. Not the first one is lines. Then we'll take a line at index 0, like that. Then from this, again, we're able to just extract the path like this. Then you can have multiple variables here. So method, path, and underscore. Then we'll say request underscore line should be line dot split, like this. So with this, what you're able to do now here is you're able to modify the pass and rather to modify the server to pass the request, and then extract the request path. Now to get the exact request path, you can just use multiple if statements to try and get everything going. So to do that, we'll just do it right here, and at the same time, so we'll just say if the path should be in lowercase, just simple if statement. So we'll just say if the path is, for example, if the path is just / like that, it should be a double equal sign. If that is the path, we we print a specific statement. So what basically this is doing right now is instead of allowing, or rather instead of always returning the hello world statement that we saw earlier on, we can now respond with different pages, and those different pages are going to be dependent on the specific path. So if the path is just forward slash, just say request, just say request underscore body. This should be response, not request. So response underscore body, and then we give it a statement, and in this case just make it some HTML. So you can just write some, make it a H1 and say welcome to my web server, welcome to my web server, and then we just close it off the H1. So with this, then you can go ahead and check other paths as well. So you can just say if the path is, so let's say if the path is about forward slash about, this is an about page that we're trying to access, then I'll just change this and say welcome to about page. Then we'll say else. We can have again just have the same thing. Then we'll say for not found in this case. For not found. Should close this. Okay, awesome. Then from here again we have our responses down below. So now we'll change this response. Instead of having this statement, remember we had coded the hello world earlier on, which is what we're able to see here on this simple web server. So now we can just get rid of all this. Then we can use an f string to try and customize everything. Actually, let's just go back. I'm going to remove this, and then we'll get the 200. Okay, we're still going to use an f string here. Get the 200. Okay, then forward slash n is a here content. So content type, content hyphen type. Then we say the content type would be maybe text. So text HTML, then \n \n, and we pass in now the request body, not the request but the response body. Response should be an s here, response underscore body. So what this is going to do is it's going to take the specific response body here depending on what the request is going to be. And then so we're sending everything, we're encoding the response here as well, and then we go ahead and close the socket as we're doing. Just get rid of that new line there. Then now we can now multi-thread the server. So to get to multi-thread the server, okay, I don't have to write the comment there. I'll just say while true. Should be while true. So to do that, to basically now multi-thread the server, we'll just set tag here client underscore socket, client underscore socket, and client address, client address. We'll check this, then we just say server underscore socket, server underscore socket dot accept, just the same way we did earlier on, dot accept. So with this we're able to get client socket, and so we had already done this earlier on here. Just allow me to get rid of all this. After doing this, the next step, the next thing we're going to do is, okay, we actually need some of the statements that were here. So I'll just copy this line, then I'll get rid of all that. We just needed to take all that and have it here. Then we'll say where the connection is coming from, and then we establish a thread. So we'll just say thread, then check now threading that we imported earlier on. So tag threading should be threading dot thread, Then this is going to take in the target. So we can specify a target here to be a handle underscore client. Then give it args to be the client socket, client underscore socket, because this is a tuple, so we need to just add the comma there to show that there is nothing else coming afterwards. Then we'll take thread dot insert the thread, that is, so thread dot start, like this. So now what you've been able to do up to this point is set up multi-threading, so they can be able to handle multiple clients. And how we expect it to work is that each time a client connects, we're going to start a new thread. Then the request is going to be handled independently from other clients, and it will allow multiple users to serve simultaneously. And we can go ahead and just test this out and see what we get. I believe our server is still running, but I'll just run it again. So I'll say python 3 server.py. Again, still listening at port 80. Then using curl, we can send this request to that port. So you can see now it's saying, welcome to my web server. And this we're going to just port 80. Then let's say we go to about. You see it says welcome to about page. And then let's go to a page that does not exist. So let's say it's a contact page. Then you see it gives us a 404 not found, which shows us that this page is not there. And yeah, that's basically it. So basically how multi-threading behavior is expected to occur is that all requests should return quickly and independently, and you've seen that. And the server should not freeze or crash at any point. If one request is slow, we also expect that others should still complete normally, because again that is the expected multi-threading behavior once you start using multi-threading. Now what you can go ahead and combine everything and write a Python server that is a bit more complex than what you've done, but these are the fundamentals that are required at the end of the day. Yeah, so thank you for watching up to this point. I do hope that you've been able to learn a thing or two about how a web server works, how to accept connections and handle HTTP requests, how to send back these responses dynamically, and how to use multi-threading for multiple clients. Thank you, and we'll meet on the next one.